Okay, today I'd like to talk a bit about our chosen control software which we use for our mercury CNC machines. It's a program called UCCNC, which you can see on the screen, and this is the main screen you would be working in all day long. Okay, why did we choose it? Because number one, it's rock solid, it doesn't crash, it controls the machine perfectly, and it's very customizable. Just for instance, the tool change software that I've written to control all of the tool changes, etc. Everything was written in C# and it's based inside this program. You can see across the top here, this is the tool changer control section, which is very simple, just numbers, and it shows the tool position numbers, so position 1, 2, 3, 4 up to 10, etc. And then underneath we have the tool numbers that we're going to use in the program underneath. So if you look here, this one shows in the code, it shows the tool used is number 58, and we've got number 58 up here. Okay, so that's the tool we're going to use, and that's the position it will pull from the tool rack. Now, unlike most controls, the software routine that we use for the tool changer allows you to use any tool up to number 96, so 0 to 96, which means you don't have to have, for example, tool 1 in pocket 1, tool 2 in pocket 2. You can put, just for example, you look at pocket 3, we have tool 75, and pocket 4 we've got tool 2, pocket 5, standard pocket 5 is we've put tool 5 in, but it's whatever you need to use from your program. Okay, we'll go through the screen set a little bit and show you what we've got. Okay, so the start of the day we have the home all button, which is down at the bottom. You can see the cursor here, and there's the home all button. So once we start the program, the first thing we do is home all, and you'll see that I shouldn't have clicked that, because I think I've kicked this out of the program. No, I haven't. Sorry. So we've got the home all button, which sends the machine to the home position, and when the machine is in the home position, the machine coordinates here will show the distance we are from the home in switches, so that's where the machine stops. And it also lights up the reference for X, Y and Z to show us that the machine is homed in all those three axes. Now we can reset, just for instance, we want to rehome the Z position, we can click this button and it will rehome, and you'll see this go to 0, and it will set our work coordinate. Alright, so the machine coordinate here, that is just for, it is actually where the machine is in its own space from the home switches. Something you don't have to worry about all day, because this is not what you're using. This is used for the probe position, the ATC position, etc. So you can totally disregard this section of the screen once the machine is running. The work coordinate is what you're going to use, which is here. Now this would be the position of the machine from your 0 point. Okay, and it's just, for instance, I've scrolled in, I've loaded some code. At the moment the machine would be in the park position, and the 0 point here, which is shown by this circle, that's the 0 of the job. Now the machine is at the park position at the moment, which is right up in the corner, so it shows you it's 2.4 meters, or 2472 meters away from the 0 position, and likewise 1268 away from the Y position. If we actually run the job, so if I press the cycle start button, and you can see I've got the code on the screen, so if I press the cycle start button, you'll see the machine will move into position, and you'll see these numbers move. Okay, so that will come down to the 0 point, and you'll see it come in here. There we go. And this is actually the machine doing the job, and you'll see the green lines which it's tracing. That's where it's already been. So I'll let that run just for a second so you can see that. Okay, so this is the tool path it's going to make from your code. Okay, so you can see it's tracing the green line to show you where it's already been. Everything else you see on the screen, the blue lines, are all of the profiles, etc., which are going to be cut. And the red lines are the rapid moves in between. Excuse me. Okay, so let me just hit the stop button on that a second. Okay, so that's that was the code running. So we'll go through the home switches, which are the reference points, and you'll see these light up green. Okay, on the right hand side we've got the standard things like cycle start at the top, feed hold, which stops the machine but leaves the spindle still running. So if we click that, that will flash and the machine will come to a halt but leave the spindle running. And we've got cycle stop, which will just stop all movement and shut the spindle off. Now, if you use the feed hold button when the program is running, if I hit cycle start, so now the machine would be stopped but the spindle will be running. If I release the feed hold, the machine will just continue. If I do press the stop button, the spindle will stop. Now you can restart from here just by clicking spindles clockwise and then cycle start, and it will continue on its way. So once the spindle is up and running from the stop position, you must restart the spindle manually and then click cycle start and the machine will continue. Obviously if you forget to click the spindle on, then the machine is going to try to run but without the spindle running, which is not what you want. Alright, so that's just something to look out for. Okay. Other things we've got on the right hand side, so we've got single line, so if you want to just go through one line at a time, sorry, I'll stop that a second, single line, and it will just move one line at a time of the code. You can see it here, and it's stepping through the code and it will move just one line at a time. You can see the y-axis moving on the screen, which is here. So every time I click single line, it'll just step through a little bit to the next line of code where it's supposed to be. Okay. Now let's have a look at the control for the code. Okay, so we've got close, we've got load file, edit file, rewind file, and close file. So if we close this one off, and that just shuts down, takes the code out of the machine. Okay, so if we want to load code, I'm going to load a different file. I'm going to load a huge file just so you can see, disregard where the mouse is on the screen because you can't see what I'm doing in the background, which is just opening the file. You can see this is a huge file and it will come in and then generate a toolpath. Now this is, let's have a look. If I scroll to the end of the file, that's 44,810 lines, so quite a big file. It takes about 2 hours to run. Okay, so if I hit rewind, it will go back to the start of the code. Let me just show you on the top here, we've got the name of the file, we've got the date. It tells you it's the Mercury CNC ATC post, so that's what we've used as a post processor from Vectric. And it gives you the Z0 position is material surface. So that tells you that is where you must zero your machine to. So the 0 point is where you take the bit down to the work and then zero the Z-axis, which would be here. So once you've jogged it down, you touch the top of the work, click this button over on the left, and that will zero the Z-axis ready to run. Okay, underneath that it gives you the material size, which is taken from Vectric. So what you've set the job up as, in this case 1000 in X, 600 in Y, and 40 is the Z depth. Now the very important thing here for the ATC, when we use the ATC, we must ensure that the tools used in the program are already in the tool rack. Just for instance, we're going to use tool 6, 5812. These are repeats, 58.6, 58.12. So we must have tool 6, 58.12, and at the end we've got 2. Alright, so we have 6, 58, 12, and 2 already loaded in the tool rack. Now, we must have that, otherwise the tool changer will come up and give you an error saying it can't find the tool in the tool rack. So that's something always to check. Once you've loaded your code, make sure the tools that are used in the code are in the tool rack. Okay. Now at the moment the machine would be loaded. It's got tool 58 in it, which is shown here in the grey box. Now basically from that we can press cycle start. The machine is loaded, it's zeroed on the X, and we can just press cycle start. You can see there's a slight delay at the start where it waits for the spindle to kick in, which is about 4 or 5 seconds on the machine. And now you can see the green line starting to do its work, which is where the spindle position is. Now we can change the display to do lots of different things. We can have job follow, so it actually moves with the machine. This is the job follow button. We switch that off and the display will show exactly where we're going to go per piece. This can be shifted around the screen using the control button and the mouse. Alright, so we can bring it to there. If we use the mouse wheel, we can enlarge it. Alright, so if you've got a very big sheet and you want to see the detail on it, that's our toolpath view. And we can also see it in different dimensions. We can go ISO view, top view, etc. Alright, so that's a front and top view. The normal view that we would use would just be the top view, which is this one. You can see also we've got measurements on the screen. This is showing the job size, the outside of the job, and we can turn the measurements off here on this green button. If I press that, the measurements disappear to make things a bit clearer. Alright, so as you can see, the machine will be going around doing its job, doing its cutting work, and you can see exactly where it's moving, following the code, which is in the right hand side. We've got a brush button here, which allows the dust brush to be moved up and down. And I'm just going to stop that code from running, just so it's not moving everything on the screen. Okay. So we've got the load file, we've got rewind file, and we've got close file as we need it. And we can also edit the file. If I click on that button, it will bring up a notepad editor. So if there is a feed or something that you want to change and you know how to edit G-code, you can use that. When we finish the code, so when the code is finished, we've got park positions. Go to park 1, which takes the machine up to the back left of the machine. We got go to park 2, which is the front left of the machine, which allows you to, for instance, change tools by hand, check that the tool's still sharp, make sure the tool's not chipped, that sort of thing. Obviously only when the spindle's off and the machine is safe. Let's have a look, what else do we need? We've got the probe button, which is here. The probe would allow us to reprobe a tool or probe a new tool which we've already put in. So once we've dropped a tool into the rack, just for instance, our last program didn't have tool 12, we can drop tool 12 into position in the tool rack. So we enter 12, enter, and then we would hit the probe button and the machine would go pick up the tool and probe it. At the moment it's in demo mode and it thinks the spindle's running because it's not seeing an input and it says it can't probe, so we've made it so it's safe. Excuse me. Okay, the only other thing to talk about here on this screen is the fixtures. Okay, so G54, and we've got 55 up to 59. G54 is where the machine starts up every day. Now this would normally be set as the bottom corner of your work, so the XY is at the bottom of the spoil board on the far left hand side, which is where most people would work as an origin for the machine. Now that allows you to set the origin once. Once you've set the Z 0 for your work, you're ready to go. The other fixtures like 55, 56, 57, these can be on the board for jigs, fixed position jigs, vices, etc., whatever you need to bolt down to do your work, and it saves you from having to reset this one all the time. Now some manufacturers only allow you to use G54. We allow you another 5 spare fixtures. So just for instance, on my machine that I use daily, I have G59 set as a vice, which allows me to go straight to the vice, put a piece of work in, it's already set up, and I can just press the cycle start button, away I go. It's a fixed position vice with fixed stops, so as soon as I've pushed the work up to it and clamped up, it's in exactly the right position, and the machine remembers this all the time. When you've done the probe, if you look in the tool section, just for instance, if you probe tool 1, the machine records the length of tool 1. In this case, you can see at the top, 66.59 millimeters. It's actually recorded to about 10 decimal places, so it records very accurately, but we only display it as 2 decimal places because we work in metric. 66.59 is perfect as a read-in. You don't need 66.59244482, whatever the machine is. It just shows it as a rounded up figure. So like I said, we have 96 tools, and you can see it goes up to 96 here, so tool 49 to 96 is on the second tab down. Under the user screen in the tool section here, we have test things that we can use, like the brush up and down test here, which will test the brush will go up and down and test the sensor, which will show here, ATC forward and back and repeat, and it will show the ATC sensor. It also shows if the spindle's open or locked. It shows if it's got a tool in, it shows if the spindle is running, and it shows if the spindle button is pressed. Up on the right hand side we have the large diameter tooling probe button. This is if you have a spoil board cutter, etc., which is too big for the probe. The probe is got a 20mm disc on it, so anything bigger or with the tips out further than 20mm, you need to use the large diameter probe button. This would only be a very occasional use thing for, just for instance, if you put a new spoil board cutter in, then you'd use the large diameter probe. A spoil board cutter is normally 50 or 63mm, and that takes you into the routine for just large diameter probing. For all other probing, normal tools would just be this button here. We've got, let's go back to the main screen. We've got the normal manual probe button here, and if I switch this one on, you'll see that it says tool probing on. Now with tool probing on, every time the tool changes from the rack, it will go and measure the tool automatically. So it will pick up a tool, then it will go and measure it. Now that's the default in the mornings, to make sure that any tool that's not been probed will be probed on the first run of that program. In normal use, if you're using the same tools every day, in the morning you just switch it off. It's on for safety, just to make sure that the tool does get probed, so you haven't got any mismatch of tool lengths. So to switch it off, just press this button until it says tool probing off in the display here. Okay. At the moment the code is asking for a 3000mm per minute feed rate with a spindle speed of 16,000. Now these can be upped. If you look at the spindle speed the feed speed going up, Every time I click this, it goes up by 10%, down by 10%, or if I want to take it straight back to 100%, exactly where it was, click the R button. The same with the spindle speed. If you think the spindle is running a bit slow, you can click it up 10% per time, or down 10% per time, to get right to the sweet spot. Okay, and again, if you want to set it exactly back to the set speed from the code, just click R and it'll go back to 100%. That just about covers the main screen. So we've got our work coordinates, we've got how to load, edit, rewind or close a file. We've covered the probe. We've got the brush up and down button here, which is for you to use basically if you need to see the tool, or if you want to see the work as it's being cut, you can lift the dust brush. Okay, within cycle stop, you can go to part 1 or part 2. That's the positions at the end of the code it will want to go to. Press part 1, that is exactly where it would finish on the code. Bring it towards you, part 2. If I want to send the machine to the 0 position of the work, I can click go to 0, and you'll see the cursor come down to the 0 position, and this is the cursor here. Alright, so that's gone to 0. Let's have a look. We've got offset screen. You don't really need to know that, apart from if you want to set a fixture, you can set it exact or check it in here. You can just click on these to set which one you want anyway. We've got a settings screen, which you won't be touching unless we ask you to change something. Just for instance, if you tell us you've got a very slight error, we can modify in the settings, give you the setting, change it, press save settings, it's done. Diagnostics we may ask you to look at some point, to give us a little bit of fault finding information to help you out, to make sure we know what the fault is with the machine. Normally you don't use any of these. You may use the tool section to just check a tool has been saved, but normally you just run in the main screen, which is over on the far left. I think that just about covers it with the main screen of UCCNC. Like I said, it's a very powerful program, absolutely fantastic to use, very simple, much easier than a hand controller. Once you get the layout of the screen in your head, it's very, very quick to work around. I've been using this now for nearly 8 years myself. I've done all the modifications in the programming. Lots of things can be added later, like lasers, drill blocks, that sort of thing. I have all the code for all these different items, and they can all be added to a machine if required. Anyway, hope you've enjoyed the quick tutorial sort of talk through. Remember, cncrouter.uk, where you get proper service, proper technical advice, and our prices are not bad either. Thanks for watching.